Thanks everybody for being here. Looking forward to my session. So as you can see, obviously every presentation in conferences like this needs to have an AI in the title, and I'm no exception, but it's really more about the effects of AI on your software delivery lifecycle and what you can do about it. Okay, but before I get started, a little introduction about myself. So my name is Sven. I'm a sales engineer working for a company called Digital AI. And since these days, like, business cards are not so much in fashion anymore, also I decided I should just go for a simple and straightforward email address. So anybody who wants to get in touch with me will find me on LinkedIn or can just send an email to Sven at Digital AI. And it was not always so easy to get such an email address, and I do realize that email is a bit of a communication tool from the 20th century, but in any case, anybody here from IBM or ex-IBM? Oh, okay, at least one person, because I spent a big part of my career at IBM. I started in '99 in Böblingen in the mainframe lab that they had back then. And I saw some of my colleagues, they had cool email addresses. Like there was a guy, his email address was mp3@ibm.com. I said, how can you get that? And so, of course, when you wanted to do something at IBM, there was a process, and usually there was a Lotus Notes database involved with it. So people who don't know Lotus Notes anymore, it's better that you don't know. So there's this database thingy, and so I put my request in and I said, yeah, I need a new email address. I need Sven@ibm.com. Okay, so 1 week later, request was declined. It doesn't follow the corporate policy with email addresses. So, but the good thing was at IBM back then, every employee had a mainframe user ID and mainframe access. So, and somehow I found out you could log into the email system and you could just change it yourself without any approval process whatsoever. And so then I got Sven@ibm.com, and I was very happy about it. And now in my current company, it was a bit easier. I just asked our support nicely, and here I am. All right, so much for my email address. So let's have a look at what we are going to do today. So the idea is really to talk a bit about an AI-governed software delivery process, software development process, and a big part where I'm focusing my time today will be on predictive risk, so to predict risks that are associated or that can occur throughout your development process. So first of all, I'm going to start to put this a little bit into the DevOps context. So for instance, how would that fit in with something like DORA metrics? Then covering a little bit about the features, value. I will do a little live demo, so let's hope everything works and connectivity is fine. And then, closing the session. So our company vision is, that was a bit too fast. Our company vision is to empower faster and safer delivery of software. And I don't know why this always continues, but the big part here is really safer. So obviously everybody wants to be faster, but we believe it's not just good enough to be faster, but it's very important to be safe when it comes to releasing software, especially when you are like a big company in a large regulated environment. So what we see nowadays is like, I don't know what's wrong with my presentation. Give me a second, please. Okay, I have no idea who was messing with my PowerPoint. Must have been one of those AI agents, but then let me just do this differently. And then let's just use a PDF, sorry about that. So then let's go through the... So actually what I wanted to say regarding this chart is that we are right now entering, and now my headset is failing. All right, looks like I should have prepared that a little bit better. Sorry about that. So what I wanted to mention about when we talk about modern software development is that we went through like 4 distinct waves, starting with the mainframe, where you could actually change your email addresses, very simple, then through the PC and internet occurrence, then the wave 3 with the mobile and cloud that happened like 10, 20 years ago, and now obviously we have another big change coming in that everybody is aware when it comes to the AI-assisted development aspect now. And when we look at the early adoption focus of those AI utilities, AI tools, most of it has been in the coding space. So when we look at the coding space, I mean, everybody in this room will use some sort of chatbot to help with his or her work. So be it a Copilot, be it Claude, be it ChatGPT, and name them. And a lot of effort has been really spent in that part. And I doubt that there is a single company out there that's not doing this today. So obviously this is very common and very ubiquitous nowadays. Now, the thing is, that's just one part of the entire software development lifecycle. And many of you will have seen like reports and statistics like how much efficiency boost will a developer get. And some are more optimistic and put this in like the 30, 40, 50% range. Some are a bit less optimistic and put this in the 10 to 20% range. But the thing is, when you look at how much time actually people spend writing code. So when you look at a typical development organization, how many of those people in the development organization are actually developers? So a good estimate is it's about 50%, because then we have project management, we have product owners, we have testers, we have quality people, so we have managers. So about 50%, even in a development organization, are only developers. And then when you look at how much time does a developer actually spend writing code? So I think every developer would wish that he or she could spend like 100% of his time writing code, but the reality is just different. You need to write your emails, you need to attend your meetings, you have to do some planning, you have to do cleanup, and so actually at the end of the day, it's about 25% actually time that you spend writing code. And then now when we apply the improvement gains that we get from the AI-assisted coding tools, so let's assume really in the range of about 10 to 30%, but when you accumulate all of that, what we find out is that it's about 2.5% overall improvement when you look at your entire development organization. So it's good for a single individual developer, but when you look at the entire organization, your entire throughput, it might get like 3% better. And that's why we believe the true value comes when you really unlock the upstream and downstream potential as well. So when we, oops. So when we look at, for instance, the coding side we just mentioned, when we look at the planning side, so somewhere your features, they need to be planned. So you need to use a tool like, I don't know, Jira Align, or if you do this in Azure DevOps or somewhere, your stories are being created. And then like some test cases come out of it, and so on. And all of this time, and this is also an area where using AI-assisted tools can help quite a bit. The same when you look a bit further downstream after the coding part, when we look at the securing part, like how do I make my software secure? So there are the obvious things like, okay, I can do the dust and SUST scanning and so on. But for instance, take a mobile app from your bank. So a mobile app from a bank is really secured very well. It's hardened, the code is obfuscated, it's protected against tampering and so on. And this is quite a difficult process to manage. So a lot of manual effort needs to go in there. And here as well, if you put like AI in that here, that can also help to improve that process quite a bit. And then the story goes on when it comes to testing. So when you employ like agentic testing, this will unlock a greater potential. And on the right-hand side, when it comes to delivering the software, to releasing the software, like deploying it, making packages out of it, again, a similar potential. Now, don't put too much focus on the numbers here. Obviously, our marketing department also had a say in here, but the message, in my opinion, is still clear. There's quite some value to unlock before and after the coding as well. And if you don't do that, you're missing out a lot of the opportunities that the AI power can help you with in your development workflow. I'm left out a little bit, and I'm still struggling with my presentation apparently. So a part that I didn't mention in the previous chart, and this is actually the main focus of my presentation, is what we see above here, this predictive intelligence. And so if you take all of what happens in a software development lifecycle, like really from the planning side to the coding, to securing the application, to testing the application, releasing and deploying the application, there's like tons of data that are being generated throughout that journey that can help a lot with analyzing that process and can help you a lot with predicting what will happen. And that's something that I'm going to spend some time on now. So for instance, if we look at this part here where we talk about changing one single line of code cannot have such a big consequence, can it? And what I'm trying to say here is that what we saw earlier, so we have this increase in code from the developers because of the rise of the AI agents. So that means the AI increase also increases the deployment speed, but also the deployment risk, because I mean the code that sometimes comes of those AI agents, everybody knows that it can introduce non-obvious side effect. So, and what many companies still do, this bullet here, human reviews alone cannot do that anymore. So especially big companies that typically have a thing like a change advisory board. Anybody from you have change advisory boards? So I mean, before a change gets put into production, like a dozen people look at it and say, well, is it dangerous? Is it not dangerous? What do you think? What do you feel? How was the past performance? And yeah, typically the assessment will be, yeah, it's going to be fine until it isn't. And so that's why we're saying you need something like a predictive scoring to get rid of those manual processes that you have in a change advisory board. And so how would that be put into practice? Let's first have a look at the DORA metrics. So I assume most of you know what the DORA metrics are about. It's maybe not as hip anymore as it was a few years ago, but those are metrics from the DevOps Research Institute and Google that look at how teams write code and put that into production. So there are 4 metrics here. The first metric is change lead time, the second is deployment frequency, and then we have change failure rate and failed deployment recovery time. And now the first 2 metrics here, they are mainly concerned about like when you want to be faster, about increasing the velocity of the change, whereas the later 2, they will the goal should be to decrease the impact of failures. And now the interesting thing is that what you can see down here, that for good teams, for well-performing teams, actually all of those metrics, they move along together. So it's not that we see something like, okay, change lead time is decreasing a lot, and this could also lead to a higher change failure rate, but that's not typically what happens. So what we really see is that teams who are really working well, all of those 4 metrics, they move along with each other. So that's good news, actually. So that means it's not that if you modify one of those parameters, then that another one will fall short. So the good news is really it's possible to do that. Now, the thing is that when you want to do that, again, you don't want to sacrifice speed for stability. But what we can see nowadays is when we go back here, and for instance, we can see like the change lead time. I mean, change lead time is basically the time when you created a change request or when you created your story until it's actually put into production. And now we can imagine that when people do this with AI nowadays, that this might decrease. And so there's a certain imbalance being created here. So lots of more code is generated, but maybe the other processes don't catch up with it. So we could see now what we didn't see up until now, that we will have a problem with an increase in change failure rate. And so that's why we're saying it's very important to embed a risk management into the entire process here. So, and what I'm meaning by that is to put an intelligent change management process into place here. And so what this chart is trying to say is that we have all of those changes coming in that will hit my production soon. And so maybe up until a few years ago, I only had those normal changes, like the orange ones here. They were from a development team, they were tested, and now they need to go into production. But nowadays, we have what we call here those AI-assisted changes, where in addition to the normal changes now, we have a ton of additional changes that have been created with the help of AI. And so that means the number of changes just goes up quite a bit because of that. And as you can imagine, and I saw some people were nodding when I was asking about a change advisory board, now reviewing all of those changes is a very difficult task now, because just of the sheer volume. So some of our customers, they do like 3 change advisory boards per week when every change is being reviewed. And with the increase in changes, it doesn't scale anymore. It's really impossible to do that. And so what we are proposing is, instead of doing a manual change advisory board for all of those processes, let's have one that is assisted by some intelligence, which we call change risk prediction. And so what you could implement instead is, instead of having the change advisory board look at all of those changes here on the left-hand side, what we can do is we can, first of all, execute our risk prediction engines on that. And then, if you're honest, I mean, most of those changes typically don't have a very high risk. So there are very small changes, they are from experienced teams. So it's not very often that you have a risk that is really very dangerous and that can cause really production issues, production outages, and so on. And so that means, actually, when the risk prediction engine says that, okay, that's a very low risk change and there's probably not going to be a problem with that, then why would any human still have to look at that? And so the idea is really those changes, maybe in the 80 to 90% range, they are approved automatically. So no human interaction is necessary. You don't need to waste your time in a change advisory board. And so all of those are like approved automatically. And this leaves just like 10 to 20% of those high risk changes, where now we can still do like the human review. So, but now we only have like 10 or 20% of the changes that I previously had to look at, and this takes a lot of burden away from the change advisory board. So this will already help quite a bit. And that's what you can see here in the first bullet here. So to augment the change advisory board reporting with enhanced data so that you are able to do that. Then, in my opinion, and I will show this live also a little bit, is the third bullet here, my favorite one, is to enhance that process by providing an API to access all of those changes and embed this in your delivery workflow. So that at the end of the day, you can pretty much put code into production without that a human looks into it and has this task in the change advisory board. And I will show you in a minute how this can look like in a real environment. All right, so and the really the big news, the big features about that is really the purpose is to identify risk before they cause problems and before they cause failures. And you can't imagine how often this still happens. So when we talk to our customers and they say, okay, yeah, there's a risk that needs to go into production, and people still say, yeah, it's unlikely to cause any issues because humans being humans, I mean, nobody would say, yeah, I created a high-risk change, yeah, blame me. So everybody will say, yeah, that's not a problem. And now, but the risk prediction engine cannot be fooled so easily, and it will really show you where the issues are. And so the value of that is really to reduce the change-related impact and outages, because you will find the issues and you will see the risk before they actually hit your production system. You will have faster approval cycles and a reduction in the change advisory board effort. So we will see in a minute how this looks live. So we have a machine-based learning as risk scoring of those changes. And what we also have, and this is a big part of that, we create like a change credit score. So that's similar to when you want to get a loan, like for a car or for your house. You need to go to Schufa, and they will tell you, okay, your score is A, B, C, D, E, or F, G, or a number, and then you get your loan or you don't get it. And we can do something similar for development teams. So every development team will get a risk score or a change score associated with it, a credit score as we call it, which will help a lot in scoring those changes actually. All right, this one I will show you live, so let's not have a look at that. Yeah, let's actually just skip right away to the demo, and then I can show you what this actually means. Any questions so far before I do that? Right, I hope you can see that. That looks good. And so what you can see here is that change risk prediction dashboards, which gives you the overview of those changes that are upcoming. And so, for instance, here we have about 2,000 changes coming up in the next 90 days. And of them, let's go, maybe just go to 30 days, so we will have a little less data. And of those, in the next 30 days, we have like 2 high-risk changes and 4 medium-risk changes coming up. So bear with me a little bit with the data here. Most of this data is a bit fake, just to show you how dramatic it can look like, because if you see here, this change we scored with a failure prediction of 75%. I mean, this is almost guaranteed to fail, and I hope nobody of your development organization will put a change in there which has such a high failure prediction or higher failure probability, but this is also just a bit tuned data to give you a little bit the overview, because if I just show you we have 1,000 changes coming up and none of them is a high risk, then I don't have anything to show. So of course we need to tune the data a bit. The important thing to note here is the data that is being used here is individual per customer. So it's not that like we apply a set of policies and rules, like general policies and rules. It's really based on the data of the customer, of each individual customer. And we look at like 30 to 40 different data points to establish all of that. So for instance, we can get data from the IT service management tools like a ServiceNow, we get data from code repositories, we get data from your pipeline executions, we get data from the test executions, test results, quality metrics, and so on. And all of this is being aggregated into this risk score. And the funny thing is there's, for instance, one metric that I like a lot is the number of words when you describe a change. So people have to write a change, and so then they need to describe it. And so the interesting thing is that there are organizations where a change, when it's described with very little words, if you have a very small description, then the failure probability is higher, because obviously you didn't explain the change well enough. But then there could also be organizations where if you have a change description which has hundreds and thousands of words, then you could say, well, maybe it's a good thing if you describe it well, but this can also be an indication that it's just too much of a complex change. And so it's really interesting what the machine learning can do with your data. And the important takeaway is really, it's really individual, based on individual companies, individual customers' data, that we can calculate the risk score, and it works amazingly well. So yeah, now you can see here an example for this one. Again, bear with me, it's a fake change, obviously. And so if you see things like the change lead duration is long, 3,000 days. Well, obviously nobody would have a change with a lead duration of 3,000 days. So this is really just the tuned data a little bit so that we can see that high risk here. But the idea is still the same, and it's relevant that we can look at all of those different factors, can give you a summary of that, and can also give you some recommendations on what you can do. So obviously, I mean, this might be a bit long, so you need to change that. The CI, so the continuous integration failure rate was very high, so you need to look at that. And there are different things that we recommend how you can do, and even going down to the process improvements. So what could you do in your process to help that? So for instance, require a formal backout and recover plan for such a database change, and so on and so on. So really many parameters that you can learn here and have a look at that. Another way to look at that data is what we call a change weather forecast. So let me just refresh that, because obviously my authentication expired in the meantime. So that's something that everybody can relate to, like a weather forecast. So everybody knows how a weather forecast works. So that's why I like this example a lot when it comes to change management, because this actually shows the upcoming changes in your organization. Each of those dots represents a change that will go into production at some point in time. And then we can say here, all of those, they are green, they don't have a high risk, but on the right here, the red ones and the larger circles, they have a higher risk associated with that, where you can really say, we have a few hurricanes coming up, a few tornadoes coming up, and then you can plan the times when you want to go to the office or not. Yeah, just kidding. But here you could see that, for instance, on Sunday, it's a pretty good day. So we only expect like 9% of rain. So not many changes on that Sunday. So maybe it's a good time to go to work on a Sunday. Yeah, maybe not. But you get the idea. So this is really to give you an outlook on how your production system will behave in the next couple of days, depending on the changes that are coming into the platform. And I mentioned earlier in the presentation that a big value of this will come out when you use this in an automated fashion via the API. And for instance, here I modeled a software delivery process where you have all those different stages of your software delivery, like from development to the QA stage, and here, for instance, to the change advisory board. So this is a tool that we can use for release orchestration, release automation, release management. And here, what we can do is, for instance, at the beginning, like the artifacts will be built and compiled. We do all those typical things, like we do Sauna Cube quality check and so on. We check for CVEs with check marks or black duck and so on. Then the artifacts are being deployed, tested. But the interesting part here is now we have now this virtual change advisory board here. So what we do here in the second task is we get the prediction result from the failure engine. And so we store this in a variable here. So we can see here that the risk prediction is being stored in a variable. And then we can use that result to decide how to go on here. So we can say, yeah, we only need to run the fast lane checks for the low changes. And if we have changes that have a high impact, well, then we need to do a complete change advisory board assessment. For instance, here we do send a Slack message to the Slack channel of the change advisory board. And only in this case, we need to do the complete change advisory board. But what this means is that for 80 to 90% of your changes, all of this will be fully automated. And so nobody has to look at it. No change advisory board needs to be involved. And this is really a game changer, in my opinion, as this is really embedded in your software delivery process. So this is really just an example from a tool that we use, but it's no problem to embed that into a GitLab pipeline or into an Azure DevOps pipeline or whatever you use to automate your delivery flow. So you can just put this simple task in here, do this REST call, to the API call to the risk prediction engine, and then you know the likelihood that your change will fail or will not fail. Yeah, and so in my opinion, that's really where the big value comes in by automating this entire process. Okay, so much for the live demo. Let's continue with the slides, and then we're almost out of time anyway. Really just let me quickly summarize what the change risk prediction system is all about. So 5 small bullets here. So the important thing is really that we have this risk-based change overview. So we really know what those changes will do to my system, what the impact of those changes will be. Then we do have this detailed risk scoring, where we can also use things like what I said, this change credit score, which helps a lot. And we will give you AI-driven risk predictions. What's also very helpful, I didn't show this in the live demo, so there's also a root cause and historical analysis, which helps you, like for failed changes, to understand that. And also, and you saw that in the live demo, to see those actionable recommendations, so that for each of the changes that are coming up and that have a certain risk attached to it, we give you certain recommendations on how to deal with that. All right, that was in a nutshell what I wanted to talk about. So I want to close with this one slide here, because we have a booth over there. So booth number 10 is digital AI. And obviously nowadays you cannot be to such a conference without giving away some Lego for free. And so of course we have to do that as well. And if you're interested in anything that I showed here earlier, or any other aspect of the presentation. So we talked, for instance, also about application security. So if that's something that interests you, we can have a conversation, automated testing and so on, or also this release orchestration, release automation that I just showed, or obviously the big part of the presentation when it comes to the change risk prediction. So please stop by our booth and we can show you definitely more. If you're not interested in any of that, you can still come and win the Lego set, but in any case, you need to stop by our booth. Any questions?
I have a question.
Yes.
I saw you rely on change fail rate also as well. How do you calculate change fail rate?
Change failure rate, it's typically pretty easy to establish when we talk to tools like ServiceNow, when you do all your change management, and once you put a change in production and it fails, I mean, you can get the data from ServiceNow. So it's just historical data from the last 1 year maybe or 2 years that we need, and the change management system is one that we include when it comes to the data analysis.
So let's say a team which happens to have really good credit score, if they happen to have 30% of, let's say, risk prediction, and within the team which has, let's say, a very bad credit score and still have risk prediction of 30%, would the outcome tend to be different in either cases?
Okay, so let me repeat the question for everybody. So the question, if I understood correctly, let's assume there's a team with a good change credit score and there's a team with a bad change credit score. So how does it impact like the prediction? Yeah. Yes, so I mean, the change credit score is one of the most important factors that we look at because it really just includes the historical performance of the team. But also, even a team that's typically good historically can do mistakes and can miss things, and so it will not be the only thing that we look at. So there are other things, obviously, that we take into consideration. The change credit score is a big factor, but it's not the only factor. So we take a look at everything. And so that means even a historically well-performing team can get a high-risk change.
Yeah. Can it also happen that you ban someone from delivering a particular person?
With particular persons, I mean, you know that we are in Germany and it's always difficult with, if we go into that kind of specifics, then we have the Betriebsrat and everybody shouting, oh, you can't do like score the persons by a machine, but in theory this could be done, yeah, but you need to be a bit careful in Germany. Well, the important thing obviously is that you still need to have the entire governance about that. And so, for instance, with the tool that you saw earlier, even if it goes into production like fully automatically, you still have the entire proof because it's being governed by the tool with the rules that you set. And so you have all the paper trail to prove afterwards what happened, who did that, and who approved that. So you still have all the entire paper trail, and then it's up to you if that's acceptable for you or if you just still need a human in the loop, but then it's also no problem to do that.